Hello again, chemistry fans. We have a new thing in this section, and it's pretty different. It's a fun little puzzle where we give you some reactions. We'll give you two or more chemical reactions, often three or four. And what we're asking you to do is use a combination of these to make a new chemical reaction. And there are some rules for how you're allowed to do this. Any reaction that we give you, you're allowed to multiply it by a number if you wish. So for instance, I could take this reaction and double everything in it. Double all the coefficients. You're allowed to flip a reaction, meaning write it the other way around. So everything from your left side would go to the right side, everything from the right would go to the left. And you can add two reactions together. And if you do that, you write all their left sides on the left and all of their right sides on the right. And why would we want to do this? Because when you manipulate a reaction that way, it has a predictable effect on the delta H, and so you can take some reactions whose delta H's you know and combine them to find the delta H for a reaction you're not familiar with. This can be nice if this thing is super poisonous or explosive or expensive. You can use safer or cheaper reactions that you already know about to figure out what will happen with another reaction that's not so easy to experiment with. So this is a lot easier to learn if you're actually doing it, so let's get in there and see what we can accomplish. I'll leave the rules up here so you can look at them. So they're saying make this reaction using some combination of these two. And the way I do this, just start on the left and work your way through one substance at a time. Here is ethanol. We need to have one ethanol, and it has to be on the left side of the reaction. Reaction 2 cannot help us with that. There is no C2H5OH in here, so it can't have to do with this one. Reaction 1 does have C2H5OH, so that's great. And it has one of it, and it's on the left side, so beautiful. We can take reaction 1 exactly as is. I'm just going to copy this. C2H5. Actually, instead of just I, I'm going to write I, no change. C2H5OH plus 3O2 arrow 2CO2 plus 3H2O. Good, okay. Next thing our reaction needs is a single oxygen. Now, both of these reactions contain oxygen, and so it's hard to know how exactly we're supposed to get one oxygen. As a general rule, if there's a substance that you could get from a couple of different places, just skip over it. Come back to it later. Hopefully, it will take care of itself, because it can be very tricky to figure out what combination of two numbers is going to produce that amount. Even though we could, in this case, just get used to skipping over things that come from more than one reaction. There's usually an easier way forward. This is ethanoic acid, and we need one of those on the right. Reaction 2 has ethanoic acid, and it's one of it, so that's nice, but it's on the left, so we'd need to flip reaction 2. Reaction 2, flip. So when we flip this, the right side stuff goes to the left. 2CO2 plus 2H2O, arrow. The left stuff goes to the right. CH3COOH plus 2O2. That's all our reactions, so let's add this up and see how we are doing. We have C2H5OH. We have 3 oxygens on the left and 2 on the right, meaning oxygen. We have some spectator oxygens here. We can cancel 2 oxygens from each side. There were 3 here. We canceled 2 of them, so there's still 1 left. So now we have just O2 on the left side. Oops, sorry, there's more to talk about here. We have 2 CO2s on the left, but we also have 2 on the right, so that's a spectator. We can cancel that. We have 2 H2O on the left, but also 3 on the right. So if we cancel 2 of those, that's all our left side stuff. All that survives is C2H5OH and 1 oxygen. On the right, we're left with CH3COOH, ethanoic acid or acetic acid, and a single oxygen. So wonderful, that's the reaction we wanted. Now, where this pays off is we can figure out the delta H for this new reaction. We took reaction 1 unchanged, which means we get this delta H unchanged, minus 1370.1. We flipped reaction 2, which means we flip this delta H. It becomes plus 875.7. And when we added these two reactions together, we must add their delta H's together. So 1370.1 negative plus 875.7, I get minus 494.4. So that's the delta H for our mystery reaction. We found it just by combining information from these first two. We'll do harder examples of those in the next couple videos, so we will see you there.